welcome back to my new videos. Designing of the PID controller by using the Ziegler-Nichols method. Ziegler-Nichols suggests the rule for the tuning the PID controller. We need to set the value for Kp, Ti and Td based on our experimental step response or based on the value of Kp that result in the marginal stability when the only proportional controller action is used. The step response for tuning the with the provision for P, Pi and PID controller settings are based on first one is the based on the sustained oscillation. The Kp value we need to set the Kp value and Ti need to be infinity and Td need to be 0. Using the proportional controller action, the increasing the Kp from 0 to the critical value of Kc at which the output first exhibits the sustained oscillations. Step 2 is note the value for Kc and the period for the oscillation T. Recommended settings for Kp, Ki, Ti and Td for different types of controllers are: the controller is the composition of Kp, Kp by Ti of S plus Kp into Td of S, and G of S is the plant and it has been feedback through the feedback aid, and E of S is the error which is generated. Here, let us consider this sustained oscillation waveform, and this will be the time period for the sustained oscillations. And now let us find the parameters for the PI controller. So that is, for PI controller the Kp value will be the 0.5 into Kc and Ti will be the infinity and Td will be 0. For Pi controller, the Kp value will be the 0.45 Kc and Ti value will be the 0.83 into T and Td is 0. PID controller, the Kp is 0.6 Kc, Ti will be the 0.5 T and Td is 0.125 T. And the controller transfer function is given as Kp into 1 plus 1 by Ti of S plus Td of S. And let us consider we have a unity feedback systems having the plant transfer function as G of S is equal to 6 upon S plus 1 into S plus 2 into S plus 3. If the transfer function model of the plant is available, the Routh array may be used to establish the critical gain K and the corresponding period for the oscillations. The characteristic equations of the closed loop systems under the pure proportional controller is given as 1 plus Kp into G of S is the characteristic equations, and we need to find the Kc value from here, and we got the range of the stability is from 0 less than Kp less than equal to 10. The critical gain Kc is 10. And also we need to find the frequency of oscillations and can be determined by using the Routh criterion, that is auxiliary equation, and it is given as omega is equal to 3.3166 and the time period is 2 pi by omega and will be the 1.895. For proportional controller, the Kp value is 0.5 Kc and equal to 5. And for Pi controller, the Kp is 0.45 into Kc, that will 4.5, and Ti will be the 0.83. It is equal to 1.572. And PID controller, the Kp is 0.6 into Kc and Ti will be the 0.5 T and Td is 0.125 T. Step response, the rise time is The time taken to rise is less, and the steady state response will be at 5. The oscillation has been reduced, and this is the response for the step response for the PID controller. Thank you for watching. Please like, subscribe.